All right, in today's session, we are going to talk more about graphics in R. So let's dive into our first example. Most of what you'll see today, you have probably seen it in some other sessions, but not gone into the details of the parameters and how you adjust the sizes and just just the graphical part of R that we're going to look at today. So there are two main packages in R graphics for basic plotting. So one is the lattice package. I think one of our previous sessions had it. The lattice package is one, and the other more frequently used package is ggplots package. So I think I've shown you a couple of examples in ggplots. So ggplots is definitely one of the high-end graphical software, and your plots look much prettier. So today, let's just start off with our basic plotting, and then talk about lattice package, and then I'll talk about some more plotting. And in today's session, if time permits, we'll start ggplots, but mostly we won't do it today. So let's get started. So this is one data set that we are using. For example, it's an islands data set. So this data set basically has all land masses in the world, continents and smaller islands, and their land area in square miles. So this data set, again, it is a part of your built-in data sets. So if you can also type in the help islands and see what kind of data it has and just the history regarding the data. So although you can do the head on this data set and to get the data set, in order to get an understanding of the columns, you might want to search in the help to just get a clear understanding about the columns, the column names, and what values it has. So for any data sets, for almost all the data sets that we have used in this course, which are built-in data sets, you can type them in the help and look at the description of the columns. So what we are doing here is today I'll be talking about how to print. So in all our previous sessions, we did look at mostly bar plots, box plots, scatter plots, just as points. But today we learn about how to put text on your plots, how to change the size of the axis labels, and more about labeling and other types of plots. So this is our first example. So what we are doing here is looking at the islands data set. So let's dive into RStudio, which is much more exciting than to look at just text. So if you sort this data set, so let's just first look at what is in the data set. So islands, I'm just heading the islands. It's the major continents and their land area in square miles. And you see that over here. It's a simple, very simple data set. It has the name of the continents and islands and their area. So only 2 columns. So that's what it has. And you can look at the structure, class, and all that on your own. So let's just go into this example. So what we're doing here is first sorting this based on the area, the land area. And we wanted to display it in a descending order. So the top largest land area, continent or island will be displayed first. So let's just sort and see. Let's just run this. So it's a decreasing order. So the biggest one, and then followed by all the other continents and coming to like smaller islands. So that's the sorted islands. So what we are trying to do here, since it's more islands than, so it's if you look at how many data points there are in this islands data set, there are 48 data points. So instead of plotting 48 different points on your plot, I'm just going to print the first 10 of these islands and continents data in your plot. So you could do a, you could, if you want, you could print all the 48, but it's going to be overlapping. Some of the names are going to be overlapping on each other. So I just chose to take the top 10 from this data. So this is a plot. You have seen it before. So plot will just do a scatter plot, and we have looked at other types of plots which are inbuilt in R. These do not belong to any packages. They are inbuilt in R, and they load with some of the basic packages that R comes with. So plot, we have looked at box plot, we have looked at bar plot. So all these functions are pretty inbuilt in R. And later on, we'll look at the other package, lattice package. So if you use plot and use the head, the top 10 data, in the previous, I think you remember, if you give main parameter, it's going to be the title of this plot, and you could name the axis by X lab and Y lab. So that's X label and Y label. So here I have land area in square miles. And let's print this plot and see what we get. So here we are just getting land in square miles, which is the y-axis, and then this is just the index. So index really doesn't mean anything. It's just, since we have arranged this in a decreasing, sorted this in a decreasing order, it's going to be the first, second, and so on. So this, as it is, this plot doesn't give much information. You'll have to like print out some of the names beside it to be, for this plot to make sense. So we are going to use a function called as text. So text, what it does is it prints labels on your plots, and you can give it your full data set. You can give it your full data set and also give it the labels. So labels parameter takes in the exact names that you want to print at this data set and this data points. So when you give names of this variable, it is actually the names of those continents and islands. So you want to print these labels on the plot, put them on the plot at the data points that are present in this variable. And we are going to put that over here. So I'm going to leave this finding out this to you. So see, these are some of the adjustments that you do, and that depends on, and this will adjust where you want the label to be printed, whether you want it on the dot or above the dot or beside or on, left side, right side, below. So figure this out on your own. And so that's pretty much going to be the plot. It's going to print out the names. So that's pretty much our data set. So this is another data set that we are looking at. You might want to look at the description of this data set. It's called Faithful, and this is data about an old faithful geyser in I think it's Yellowstone National Park, and that geyser, it erupts hot water and periodically, and they are trying to collect data about when the eruptions occurred, how long the eruptions occurred, and when what is the waiting time until the next eruption. So as you can see on the y-axis here is so this data set basically has only two variables. One is eruptions and the other is waiting time. So the eruptions is the actual time period of how long that eruption lasts. So it's mostly, I think it's 1.5 minute, 2 minutes, 2.5 minutes, and so on. And this is the time in minutes of, so both are minutes, and this is the time in minutes of how long there is until the next eruption. So if you just make a plot of this, so plot, if you remember, it just gives a scatter plot of all the data points. So it takes whatever data there is, the first column as the X and next column as the Y, and it prints a point or a circle at wherever the data is. So if you plot the faithful data, it's going to print the data points like this. Now, what we want to do, this is not something new. We have seen this in the previous sessions, but we want to be able to color a few of these. So coloring, depending on certain conditions, is something that you want to be able to do mostly. And what we are trying to do is color those data points that have eruptions lasting less than 3 minutes. That means for the eruptions to last less than 3 minutes. So in the last class, we have seen that there is an easier way to subset a data set with using this width function. So width, you give it the data set and then you give it a condition of your subsetting. So what we are doing here is we are selecting those rows which have eruptions time period less than 3 minutes. So we are subsetting this data set, putting it in another variable short eruptions. And so you'll first plot your whole faithful data and then use a function called as points to be able to color specific points in your plots. So you use the points and then you give it the subset of the data that you want to color, and you give it the color using this color parameter. And PCH is the type of points you want to put. So PCH, I would want you to experiment with this too, because different numbers give different types and shapes of these, selecting the subset of data. So 19 is a solid circle, and you can put a lot of other shapes in this depending on which number you choose here. So this is just going to color your subset of data. So let's try that out in our RStudio. So this is just going to print plot faithful. Here we are going to subset this data depending on what eruptions and how what eruptions last less than 3 minutes, and it's going to have, let's just check. So we have 97 of these data points in the short eruptions. So we have that. In order to be able to color those data points that are less than 3 minutes in this plot, we will use this points function and pass it the subset of data sets that we want to color, give it the color, and the PCH, which defines the shape of those points that you want to color, and you see that those are colored. So for this to work, for these points to work, you should first have the plot ready, and only then the points function will work. Without the plot, this function will not be able to do anything. All right. So there is another function called points. So we saw so yeah, this is the points that I was talking about. So if you use this one, just this is the help page, you can either type it over here, or you could retrieve that points information by typing a question mark and points. So points. So this has some examples here. A lot of examples over here. If you're interested in that, you can try this out. So similarly, like the points that we added, we could add different lines. If you recall from our linear regression modeling of our data, we had used a regression line. We had used a function called AB line to draw a regression line on a plot. So we'll see similar type of functions over here. And as you know, LM, which is a short form function for the linear model, you can use this function and extract the values that can be used to draw a line. So I'll show you in just a minute how to do that. So again, let's go back to our example and let's make a linear model. Linear model, you use this function LM, and you have to be able to predict something. So a weighting or the wait time is what we want to predict based upon the length or the time period of the eruptions. So weighting is our y variable and eruptions is our predictor variable. And we are using the same faithful data set. So once you plot this, and you could either do this step or not, it's just going to color this set of plots. But so our subsection here deals with the drawing of lines, right? So we have to use this function called as lines, and you give it the eruptions time period, and because that's basically the x, the first the lines first takes in the x, and what is the y? You can get the y from this linear model fit. So if you remember from the linear model fit, you can on the fit you can use a lot of different functions like coef. If you remember from our previous sessions, the function coef of the fit retrieves coefficients of those of the model, and similarly fitted function of the fit retrieves the fitted values of the linear model, which means you have this theoretical line that your data has to fit into, and that fitted function retrieves that theoretical line, the y values of that theoretical line. So you give it the x, and the fitted values will be your y, and then you can color it differently. So you can see this line being drawn. So if you remember, I am going to pose a question here. From our linear modeling session, what is the function that we used to draw that linear model line? To basically draw that line on your points. We didn't use lines, we used some other function. Can anybody recall? So we used AB line. We used AB line to be able to draw this line. And here I'm talking about a different function called lines. You can either use this line, or you could simply use the AB line. So let me show you in the RStudio. So the LM function generates a fit. If you look at the summary of fit, again trying to recall our linear model session, if you look at the summary of fit, it's going to give us a lot of different values, and it's going to give us the coefficient estimate, the standard error, t-value, and the p-value of our predictor variable, which is only one predictor variable that we have here is eruptions. So we see that it's very significant in being able to predict the waiting time. You have these residuals, minimum, median, max, and all the 4 quartiles. And you have these statistics, the standards, the R squared, which shows 0.8, which means the line is somewhat tight. The correlation between the two is somewhat tight, where if it's closer to 1, the R squared closer to 1, the correlation is perfect. So if you have exactly the same value, say 1 to 10, and you're trying to test 1 to 10, the same values, only then the correlation is going to be 1, else it's going to be somewhat close to 1. So it can be 0.999, but it cannot be 1 unless the two variables that you're testing for correlation are exactly the same. So we have all this in our fit, and you have to plot that data first. You either color the points or not, depends, and you could draw the line using the lines. So this is again the previous, if you recall the previous session, we used something called AB line, which is the function that you can use. But for the AB line, your parameters are not x and y. You have to give it the complete linear model of the data, or you can give it the fit. So you'll have to give the linear model, or you could give it the fit, and then you'll be able to draw that line. So they are just different functions, and they take in different parameters. You could either use one of these. AB line is something that we use more commonly, so you could use that. So let's go into our next part of our session. So AB line, we use AB line here also to put another line in this plot where it's 3. So since we have colored this data, in order to visually show it, that we have some sort of thresholding to separate the two data points, we added this line at eruptions 3 minutes. So V is the vertical line that you need to draw, and you could also draw a horizontal line on this plot where you have to use H. So, and in this plot, we are saying H equals, and we gave it the mean of faithful waiting time. So we are essentially drawing a line at average wait time of this data. So we'll just try to, so you could basically draw an AB line at any point. And for some of our plots, since we have to emphasize some arbitrary thresholds, if we have to emphasize some arbitrary thresholds, we draw a line to be able to show that it's a noise level, or it's some arbitrary threshold in your data. So you could use this AB line to draw any lines on your plots. So we'll just recall all the plotting functions that we previously had. So plot is one, So scatter plots are what plots draw, the plot function draws, and you pass it to arguments. This is something very common to very commonly built-in function inside R. Also, we had looked at box plots to be able to see boxes, different boxes, and to be able to compare data in different categories. We have seen box plots, and the other type of plots that we have looked at is histograms. Histogram is basically a frequency plot. It gives a frequency just and the distribution of your data into different bins. So what we have seen previously is the MPG bins. And if you recall, this is one of our earlier sessions of a scatter matrix. Scatter plot matrix used can be drawn with the function called pairs. So pairs function basically draws a one plot for every two variables in your data frame, in your data. So if you remember, we had looked at the iris data set where there are different parameters like sepal length, petal length, width, etc. And to be able to see the correlations between these different variables, we used this scatter matrix plot to be able to see the correlations between the predicting variables. So for all of these plotting variables, these are some of the common options that you can use. Main is something that you can use for each of these: plot, box plot, bar plot, histogram, pairs. You could use the parameter main, you could use X label, Y label, axes, you could use legend, you could use text, and there are a lot of other options also you could use in any one of these plotting functions depending on what you want to do. So there are a lot of things where you want, a lot of times where you want the plots to look a certain way. You want to be able to have a legend, you want to be able to display the data points in certain shapes, or you want the size of the axis to be bigger. You want maybe the labels of the axis to be aligned in a certain way, like have it horizontal, vertical, have it at a certain angle. So depending on whatever you want, there are options available. And one such option is this labeling axis. So labeling axis is you can do it within the plot. There is an option parameter called LAS. So LAS and different numbers for this LAS means different things. So your default is always 0. That means your labels are parallel to your axis. If the LAS is 1, then your labels are horizontal. It's 2 is vertical and 2 is perpendicular, then 3 is vertical. So let's just try this one example to see what this LAS actually means. So again, plot the faithful and give LAS is 1. Let's just print 2 and see. So if you look at the change is with the x-axis labels. So the previous one was parallel to the axis, and 2 was the direction of this has changed perpendicular to the axis. 3 is this has gone perpendicular. The y-axis has gone perpendicular, and 4 will be, there is no option. There is no option for 4. So there are different options, so you can try that one. And also there is, you can control whether there is a box around this or not. So depending on this, if you have this option, say BTY, it's the box type around the plot. If you give it different values, the box around this changes. If you give it the box type N, the box around this will be removed. There's only the axis and the plots. So sometimes you want different things. So depending on that, there are different options. If you give it the letter O, it has the box around it, which is by default it has a box around it. And you can change this type to 17CU, and this one, the bracket, the square bracket, to see different shapes around your plots. So you can try this one and see. So most of your times what happens is, if you want to give your deliverables, you cannot really give one plot per page. In your PDF file, you can draw multiple plots per page, and sometimes you want to be able to just draw those plots, compare it side by side, and give your deliverable in such a way that there are more plots per page. Rather than flipping through 50 different plots, you maybe want to put like 10 plots in a page. So there is a parameter to adjust that, and you can use a function called par, and give it, you can set the number of rows and columns by using this parameter within par, mf row or mf col. So depending on this, it changes to multiple formatted row or multiple formatted column. So when we give multiple formatted row equals, we have to give it two numbers. So what this means is how many rows we want it in. We want in one row and two columns. So whenever we give mf row, it means that the first number that we are giving is the number of rows that we want to specify. So in this, if we change the parameter to C of 1 to 2, we are saying we want just one row and two plots within the same row. And you could similarly change it to mf col 1 to 2. That means the plots will be one on top of the other in one column. So one thing that you have to be careful about setting this parameter is, this is somewhat sticky, meaning this is the way you change it. So this is sticky, meaning whatever plots you draw after this. So if you see it, it displayed one over here. Let me see. So it displayed another one over here. So it's giving me two plots. And if you don't change this, whatever plots you draw, it's going to preserve this format of one row, two columns if you don't change it. But if you want to change this, you'll have to reset the par to 1 to 1, which means you want just one row and one column. And that's when it gets resetted to just one plot per page. So if you hadn't changed anything and you can see multiple plots in a page, that means some point previously you had set it to multiple plots per page. So you should go back and always reset this to 1 to 1, so you can display again one plot per page. So within your RStudio, the way to save your files, you must be clear about that, is to export it as an image or PDF. So sometimes what happens is, if you're running any script and you don't have you cannot manually enter while the script is running, you'll have to have some way of saving those plots within the script. So this is the way you can save it in within your script. You have different functions such as PNG, PDF, JPG to be able to specify the format and give it the file name, and then draw the plot, and then do this dev.off. So whenever you use any one of these functions like PDF, PNG, JPG, then you draw the plot and you switch off that device, so the plot is stored in your directory wherever it is. So you can use one of this in your scripts, so your plots get automatically created and saved when you're running your scripts in batch mode. So we'll go into our faceted graphics. So this is one such example that we have seen before is the beaver's temperature, and we want to be able to separate those beaver's temperature based on some parameter. I don't remember now which we used, but based on, based on the activity of whether the beavers were active, whether they were moving around, or whether they were just resting. You wanted to see the temperature difference. So for plots like those, we want them all on one scale. So that's why faceted graphics are of interest whenever we want to draw side to side comparison. So we could either, you could either do this multiple plotting thing, and you might have these two plots, and then you might think, okay, there is a way of comparison. But this lattice library is much more helpful and better utilized made for just this purpose. So let's go back to our old example of empty cars and see how we could use lattice package. So lattice package, I think I briefly mentioned last time. What you could do is you can use this format of what you want on the y-axis, the tilde sign, and what you want on the x-axis, and you have this separator, this vertical line separating this y to x with the number of facets you want to display in your graphs. So that this Z label that you use, the Z, will divide your plots into multiple plots. So one such example is having a y-axis as your MPG, x-axis as your horsepower, and then you want to be able to see the relationship between MPG and horsepower for different cylinders. So let's just look at that example to be able to more clearly understand the lattice package. So lattice package doesn't come preloaded, so you'll have to install it and load it and transform your cars. So lattice package always has different set of plotting functions. So for our inbuilt plotting functions, we have plot, we have bar plot, box plot, histogram for hist, and such methods. But for lattice package, we have different set of functions, and for a normal plot, we have this function called xplot, xy plot, which is similar to plot in your built-in R functions. And I just showed you the format. You have to have the y-axis followed by a tilde, followed by your x-axis, and then followed by the vertical separator, and then you have what you want to separate those lattice plots with. So let's look at this example. And I have this. So I have this, and the reason I have this format is you could use another parameter to set the format. This is something random that R picks and chooses, and you can have that parameter, that format set depending on what you want to do. And I'll come to that option in just a minute. But what we are seeing here is basically for 4, 6, and 8 cylinders, we have this combined y-axis, right? So that's the advantage of lattice package. We have this combined y-axis where it's the same axis to keep this axis constant among the three categories that we are looking at for the different cylinders. So you could draw these plots side by side and be able to think that it's still better, but having the same axis, having the axis common to these groups is one major advantage of lattice package. So these groups, so this we have seen before. So the other thing that I want to show you is this parameter called type. So type has it takes different letters or it takes different letters, and P here means display the points. R here means display the regression line along with those points. So it draws this the blue regression line too along with the points. So this XY plot within the lattice package has some of these cool options where you don't have to do, where normally if you want to do it using plot in your built-in R functions, you'll have to draw 3 plots and you have to use the AB line for each of these plots. So lattice package just simplifies all of this by this simple formula and syntax and this option added within it. So similarly that you use the main X label and Y label, you could use even within the lattice package. So within the lattice package, if you use one plot, it's going to, the main is not going to be added to every single block of this. It's going to be added to the whole plot. And the y-axis, the x-axis is also going to be added to the whole plot that is in the middle of the plot, as opposed to each one of these classifications of data. So some more choices are there within, like the XY plot, like the bar plot in your normal built-in R functions. Within the lattice package, it's actually called bar chart. And this they have different names of these functions just to be able to differentiate between the lattice package functions and the built-in R functions. So we have a bar chart, something called bar chart, which makes those bar charts. And we have a strip plot, and these are just syntaxes that are different. Surface plot is called as wireframe. And more of this lattice package information, you can use just this question mark lattice and you will find a whole lot of options within the lattice package. So we'll just look at the bar charts and a few more other things, other plotting mechanisms in our class, but you can explore a lot of other different functions on your own by looking at that help page. So it's not bar plot, it's bar chart. Bar plot again goes back to your built-in R function, but since this is lattice package, we want to use, if you want to plot the bar plot within the lattice package, you have to use bar chart. So bar chart, you have what I gave is row names of these empty cars. So row names of these empty cars, if you remember, they are this long list of car makes and models. So I'm giving the car names as y-axis, and on the right side of the tilde is my x-axis, which is the MPG. So this is going to be my MPG, and it's divided based on the number of cylinders. So that's why it gave me 3 plots, 4, 6, and 8. So what you see over here is that all this y-axis names are being overlapped on one on top of the other. So to make this plot look much better, we might have to um, uh, decrease the size of this y-axis labels. So we use parameters within bar chart. So what we have within the bar chart is an option called as scales, and you give it a parameter called CEX, which makes the size of your labels half, depending on what number you give here. It's going to make it smaller or bigger. So if we give 0.5, it's going to half the size of your current label size. If you give it 1.5, it's going to make it bigger, 1.5 times bigger than the current size. So let's just do that and check if this labels improve. So I have the scale set to half of the size of the labels. So this looks much better now. That these labels are not overlapping on each other. So that's something which we try to do frequently, just for the labels to be visible, the axis to be visible, the axis to be named properly. We need to dive deeper into these options for plotting. So the other type of plot that we had in our built in our function is the box plot. So the box and whiskers plot, if you remember, shows you a box with 2 lines on the top and bottom. So it displays just the quartiles of data, and since our data here is the y-axis, we don't have anything. We are just trying to display the horsepower divided by different cylinders. Our box plots are being displayed horizontally because our numbers are actually on the x-axis and y-axis is empty in our plot. And we use this function called bwplot. So in our main built in our function, we use the function called boxplot. But similar to that, we use something called box whiskers plot, bwplot, and you have the similar syntax y tilde x separator and then z. So, and then you give it the data and the name of the plot. So similar to our XY plot and bar charts. So the other thing that we want to be able to do is grouping data. So this is something very commonly that we use in to transform our data. Mostly, if you remember some of our early sessions, if we have wide data, meaning if we have, like, say 10 columns that we want to examine, if we want to make that data in a tall format, meaning put all those columns in rows, if we want to be able to do that, we use a function called melt. So this melt function makes your data look tall. So we'll see one such example. Again, this melt function is not a part of your built-in R functions. It belongs to this package called reshape2. If you don't have it, you will have to install this package using install.packages, and you give it the reshape2. but in a minute I'll show you what that function does. So for this, demonstrating this function, we are using this example data set called Longley. So this data set has employment, unemployment related information for a number of years. So we just look at that data. This data set is built in within R. So, but you'll have, in order to be able to use the melt function, you need this library called reshape2. And you use, so let's just look at what we have in the Longley data set. So I just headed this data set and we see this GNP deflator, GNP unemployed, armed forces, the population, the year, and the percent employed. So basically it's unemployment rate, employment rate, population, and gross national product. So it's some information relating employment, unemployment. So if you can see that this data set is the wide data set format, which means you have multiple columns in this data set. Suppose what you want to do, if you see each if you see the row names or the year, the row names have been that particular year. So you have one line of data for every year. So essentially, the row names cannot be duplicate, meaning you will probably have one row for every single year. Years may be missing, but you will have it. You'll have one data set for every single year. So if you want to make this data into tall data format instead of this wide data format, you use this melt function. So let's just use that melt function and see how it makes a difference in this data set. So whenever you use melt function, you should give it an ID variable. That means an identity variable, which will be unique. So our identity variable is the year or is the row names of this data set, which is already there. So let's look at what melt does. So just head this mLongley and see. So what is it giving you? It's changing per every year. It's going to take every one of your variable and put it in this long format. So it's going to give the year, the first variable, which is the GNP deflator, and the value, and it's going to do that for every single year. And then it goes into the second column, and then for starting from 1947 to whatever end of the year there is, the second variable is going to be GNP, and the value is going to be all these values. And then beneath that will be the third column, fourth column, and so on. So it just took this data, melted it, compressed it, and put it in a long format instead of a wide format. So why is this necessary? So for most of your plotting, this type of melting is necessary. And we will see one such example why this is necessary. Here we have an XY plot. Yeah, so here we have an XY plot. So when we do this, what we are giving on the y-axis is we are giving it the value, and we are saying on the x-axis we need year, and the separator is going to be the variable. So what we are trying to do here is print all the variables and see what range of values or just take a look at the whole data. So this is an easier way of of just taking a complete look at the whole data set instead of trying to do this XY plot for every single column in the wide format. You put it in this melted format, in this long format, and make plots. So draw this plot and see. So just in one go, you can see each of these variables and where they stand, how they are distributed, what values there are, and things like that. So we have looked at this. And similarly, you can use the, this is again the empty cars data set. You can use bar charts. Here we are actually describing different colors. So we are giving it two different shades of gray, and we are using a group variable. So we are grouping the data with AM. If you remember, it's an automatic manual transmission type, and we are giving it the plot colors. So to be able to display this data in terms of whether these cars are automatic or manual, you'll have to give this complicated parameter setting of this color scheme that you have used the two shades of gray, and put it in this parameter setting colors to be able to distinguish these bars and in terms of automatic and manual transmission. If you just give it bar charts, all these will be in just in one color, maybe black. So if you wouldn't be able to distinguish those. So this is one way of grouping your data and coloring them depending on one variable. So just another minor point that I want to point you to is when you do the XY plot and when you're running this command on your command line, the plot will be printed on your right hand side. But if you're using it as a part of your script and running it in a batch mode, there will be no plot printed. So you should be able to assign this to a variable like this, and then do a print of that variable. Only then the plot will be printed. And when you're done doing it in a batch format, you want to export that plot to a file. So you will use this called trellis.device. If it was just the normal built-in R plotting, you might just want to call this PNG, JPEG, PDF functions. But since this is lattice package, and if you want to be able to save a lattice package plot, you'll have to use this function called trellis.device, give it the format, the file name, and then do print the plot, and then do device off. So that's the way you export it. And we are running out of time, so I'm going to stop it here, and we look at ggplots package in our next class. So Saturday will not be our last class. I think I'll have 2 more after that. So in one of those classes, I want to be able to complete ggplots, and in our last class, I will look at one of the example projects. So what I figured was the more and more examples I show you, the better you'll get at being able to spontaneously use some of these commands. So that's what I'm going to do. Any questions?